Hello, and welcome. Let's break down this entire image piece by piece, explaining every single term and concept in a clear and detailed way, so that it all makes perfect sense. First, let's start with the big idea at the top left, the definition of conductance. The image tells us that conductance is a, quote, measure of how easily electric current flows through a material. To understand this, imagine you have a garden hose. The flow of water through that hose is like an electric current. Conductance is simply a way to measure how easy it is for that water, the electric current, to get from one end of the hose to the other. If the flow is easy and strong, the conductance is high. If the flow is weak and difficult, the conductance is low. Now, this next point is the most important concept to grasp. Conductance is the, quote, opposite of resistance. Resistance is the difficulty of flow. Think of pinching the garden hose. You are creating resistance, making it harder for the water to flow. Conductance is the exact opposite of this, it's the ease of flow. So, if a material has very high resistance, it will naturally have very low conductance. They are two sides of the same coin. To make this even more concrete, the image gives us a fantastic analogy on the right-hand side, comparing electricity to like water through a pipe. First, it says a thicker pipe equals high conductance. This makes perfect sense. A big, wide pipe has plenty of space for water to rush through without any trouble. In the electrical world, a thick copper wire has a large area for electrons to move, so it has high conductance. Next, it says a clogged or narrow pipe equals high resistance. Now imagine that pipe is very narrow, or it's filled with gunk and rust. The water struggles to get through. This is exactly what high resistance is. In an electrical circuit, a very thin wire, or a material that isn't a good conductor, acts like this clogged pipe. And because the resistance is high, the conductance will be very low. Alright, let's move on to units, how we actually measure conductance. The modern, internationally standard unit, or SI unit, is the Siemens, and its symbol is a capital S. So if you see a value like 5S, that means the conductance is 5 Siemens. Now for a bit of history. The image also mentions the old symbol, mho, with a symbol of an upside-down omega. Before Siemens became the standard, scientists used a unit called the mho, that's MHO. Notice that mho is just the word ohm spelled backward. The ohm, spelled OHM with the symbol of a capital omega, is the unit for resistance. This clever naming was a way to constantly remind people that conductance is the direct opposite of resistance. Now, let's look at the formulas, which are just a precise way of stating these relationships. The core formula is G equals 1 divided by R. This is the mathematical way of saying they are opposites. It means conductance, represented by the letter G, is equal to 1 divided by the resistance, represented by the letter R. For example, if a wire has a resistance of 2 ohms, its conductance would be 1/2, or 0.5 Siemens. Next is the Ohm's law form, I equals G times V. You might know Ohm's law as V equals I times R. Since we know R is the same as 1 over G, we can rewrite the law this way. Here, I is the current, which is the amount of flow. G is the conductance, or the ease of flow. And V is the voltage, which is the pressure pushing the current. This formula tells us that the amount of current you get is determined by how much pressure you apply, and how easy the path is. Finally, we have the formula for a specific conductor, G equals sigma times A, divided by L. This formula tells us what physical properties of a wire determine its conductance. Let's break that down. G is the conductance we are calculating. The symbol that looks like a curvy O is the Greek letter sigma, which stands for conductivity. This is a property of the material itself. Copper has high conductivity, while glass has low conductivity. A is the cross-sectional area of the wire, meaning how thick it is. Just like a thick pipe, a larger area means higher conductance. And L is the length of the wire. The longer the wire, the more opposition the current faces, so a longer length means lower conductance. To wrap it all up, the table at the bottom provides a neat summary. For conductance, the symbol is G, the unit is Siemens, S, and the formula is G equals 1 over R. For resistance, the symbol is R, the unit is ohms, ohm symbol, and the formula is R equals 1 over G. For conductivity, the symbol is sigma, the unit is Siemens per meter, S/m, and it's used in the formula G equals sigma times A over L.